Assalamualaikum and hi. Wait, before we start, let me go get a drink first. Okay, I'm back. First, as we all know, in most cases, the solid form of a substance is smaller than its liquid form. This is because the particles are more closely packed and orderly arranged in the solid state. In solid state, the particles vibrate at a fixed position. In liquids, however, particles are closely packed but not in an orderly manner. This is due to the molecular bond that is formed between atoms or molecules. Particles in liquid state vibrate and rotate freely, which means they can still move around within the container. For example, solid iron is slightly smaller and denser than liquid iron. This means in a furnace, solid iron will fall to the bottom of liquid iron. Here is the key point. Denser structure sinks. Remember when I was adding ice to my drink earlier? I noticed that ice is larger compared to liquid water. First, let's go to the basics. Water molecules consist of two hydrogen atoms bonded with one oxygen atom through a covalent bond. In a covalent bond, two electrons are shared unequally between atoms. Water molecule form another bond, which is hydrogen bond. In hydrogen bond, a hydrogen atom is shared unequally between two atoms, which in this case is oxygen atom. Most other molecules do not have hydrogen bond. However, during the liquid stage of water, the kinetic energy causes the hydrogen bond to constantly form and break, just like some people love lives. But that's not the point here. When the temperature decreases, the kinetic energy decreases, which causes the frequency of hydrogen bonds forming and breaking to decrease. Interestingly, below 4 degrees Celsius, the kinetic energy of water molecules falls below the energy of hydrogen bond. This causes the hydrogen bond to form more frequently than they break. Beautiful crystal lattice structure in a hexagonal shape starts to form. At 0 degrees Celsius, we could see the hexagonal crystal structure of ice takes up more space than water, approximately 9% more space. So now we know that ice takes up more space than water, and that the ice structure is less dense than water. Remember when I said denser structure sinks? This causes solid ice to float on the surface of water. Why does this matter? First, let's consider our river, lakes, and ocean. As things are, ice forms on a body of water forms from top down. Ice fishing is a prime example of why this occurrence is so important. Ice fishers can drill holes in sufficiently frozen bodies of water and lower their lines to catch the fish underneath. The takeaway from this is that even though the surface of a deep body of water may be frozen, life can flourish in liquid water underneath because the ice floats. Furthermore, the top layer of ice provides insulation to the lower layers of liquid water. The deepest waters we know of will approach but never dip down below is freezing. Ultimately, the colder it is, the thicker the layer of ice that forms on the water. The thicker that ice layer is, the more insulated the deeper water becomes. This feedback system is necessary for the survival of aquatic species. Now imagine if ice were to sink to the bottom. This would cause the water floor to cover in ice during winter or in a cold climate. This prevents plant and crustaceans from surviving. Without these organisms, larger organisms cannot feed on them, and the lakes or even oceans will be dead because no organisms can live in it. Not only that, sinking ice would cause global temperature to plummet. Ice is slightly less reflective than water. Climatologists would say it has a higher albedo. If bodies of water were to remain frozen for a longer periods of time due to bottom-up freezing, the overall reflectivity of Earth would increase. As a result, more light and therefore more heat will be reflected away from the Earth and back into the atmosphere, making the temperature even colder. Decreasing temperature would mean more ice, which would mean even lower temperature, which would form even more ice. Well, you get the picture. In the end, Alhamdulillah, since ice does float on water, so now you know that ice is bigger than liquid water because its structure is less dense than water. The next time you try to make ice, make sure to use a cheap container and do not fill it to the brim. Well, that's all from me. Thank you.